acid on copper. This is a 2000 penny, so I'm not sure if it has a full copper composition. It might have a zinc core. At any rate, nitric acid, concentrated nitric acid, is a very powerful reactant for metals like copper. It will attack copper very nicely because it oxidizes. The nitrate anion is a powerful oxidant, so it has an immediate effect on copper metal. You'll see it starts to react immediately, and it produces the oxidation of the copper metal causes the nitrate anion to reduce into an oxide of nitrogen. It starts to produce that orange gas. It's a very vigorous reaction. That orange gas is actually toxic, so we're not going to keep it outside of the fume hood for very long. I'm going to cover it over, and I'm going to bring it to the fume hood now because that's toxic gas. Let's get a close-up of it. As the reaction evolves, you'll see that it generates quite a lot of that gas. That orange gas is similar in composition to what we call smog. Cars produce this gas when they have a catalytic converter that doesn't work properly because the high temperature combustion causes nitrogen to combine with oxygen in the combustion chamber of the engine. But we have something called a catalytic converter installed in the muffler that helps reconvert the oxides of nitrogen back into nitrogen gas and oxygen gas. We don't want cars pumping out that orange gas because it's quite toxic.
So what's going to happen now?
Well, it's going to continue reacting until all of the penny is dissolved, which is what has happened. And as it turns out, the penny had a zinc core. It was one of the new pennies. So I didn't get the color I was hoping would develop, which was a more blue color. And that's a sign that the penny had a zinc core. If it had been a true copper penny, that solution would now be blue, a deep blue color.